Why is web application security so crucial in today's digital landscape? The answer to that question forms the backbone of our discussion today. As we delve into the pivotal aspects of web application security, we'll explore 15 essential points, each with its own significance and impact. Item 1. The authentication mechanism. This is where we test for weak or predictable passwords, improper session management, and authentication bypass vulnerabilities. For instance, a web application that allows password inputs of less than 6 characters could be a potential target for brute force attacks. Item 2. Authorization controls. This involves checking if users can access functionalities or data they shouldn't have permission to. An example here would be a regular user being able to access and edit admin settings, a clear breach of authorization controls. Item 3. Input validation. This is about looking for places where user input is accepted and ensuring it's properly validated to prevent SQL injection, cross-site scripting, and other injection attacks. A classic example is a login form that doesn't properly sanitize input, leading to potential SQL injection vulnerabilities. Item 4. Session management. Here we assess the session timeout, session tokens, and how session data is handled to prevent session hijacking. A website that doesn't invalidate a user's session after a certain period of inactivity is a prime candidate for session hijacking. Moving to item 5, data protection. This involves ensuring sensitive data is encrypted both in transit and at rest, and checking for any potential data leakage points. An e-commerce site, for example, should encrypt credit card data to prevent it from falling into the wrong hands. Item 6, error handling. This is about testing how the application responds to unexpected inputs or errors to prevent information disclosure. An application that reveals too much information in its error messages could aid an attacker in exploiting the system. The 7th item is secure configuration. This means checking if the application server, database, and other components are securely configured to minimize the attack surface. For instance, a web server configured to reveal its version number might expose it to known vulnerabilities. Item 8. Cross-site request forgery or CSRF. Here we verify if the application is protected against CSRF attacks by implementing anti-CSRF tokens. A web application without anti-CSRF tokens is vulnerable to attacks that trick victims into performing actions they don't intend to. Item 9. Security headers. This entails ensuring proper security headers are set to prevent common web vulnerabilities like clickjacking, XSS, and MIME type sniffing. A website without the X-frame options header, for example, could be susceptible to clickjacking attacks. The 10th item is file uploads. This involves testing if the application properly validates file types, restricts file sizes, and prevents malicious file uploads. A file upload function that doesn't validate the file type could allow a malicious executable to be uploaded. Item 11, API security. If the application has APIs, we check for proper authentication, authorization, and input validation. An API that doesn't require authentication could expose sensitive data to unauthorized users. Item 12, client-side security. Here, we assess JavaScript code for vulnerabilities like DOM-based XSS and ensure sensitive client-side operations are properly secured. A website that performs sensitive operations in JavaScript, for example, could be vulnerable to client-side attacks. Next up, item 13, third-party components. This involves checking for vulnerabilities in third-party libraries and components used by the application. A web application using an outdated library with known vulnerabilities could be an easy target for attackers. Item 14. Business logic flaws. Here we look for flaws in the application's logic that could lead to security breaches or unauthorized access. For example, an e-commerce site that doesn't verify item availability before placing an order could end up selling more items than it has in stock. Finally, item 15. Scalability and performance testing. While not directly related to security, ensuring the application can handle load and scale gracefully can prevent denial of service attacks. An application that crashes under high load could be exploited to cause a denial of service. To summarize, web application security is a multifaceted discipline encompassing various areas, from authentication and authorization to data protection, error handling, and more. By paying careful attention to each of these areas, developers can significantly enhance the security posture of their web applications, making the digital world a safer place for everyone.